My name's Kevin Rutland. I'm a principal architect at Capgemini, and I lead the cloud development practice in the UK. My background, probably the last 5 or 6 years, is building critical national infrastructure, mainly based around Java technology.
Yep, and I'm Chris Burns, senior software engineer for the cloud development team in Capgemini, the team that Kevin leads up, and also a little bit of an open source contributor as well as Kevin's got experience building critical national infrastructure for public sector organizations.
So what we're going to talk about, very consultancy signposting slide. So we can talk about what it is, why it's important, what you can do to improve it using open source tools. We're going to start off with a really common pipeline, which quite a lot of people might have seen. It's probably like 5-10 years out of date now, but it's really common. And then we're going to basically break it and go through and show you ways you can improve it and fill in some gaps. The talk is all kind of unapologetically through a developer lens. I'm a software engineer, Chris is a software engineer, and kind of think it's important to be as productive as you can be, so you can give products to end users as fast as you can. Like I said, our experience is in working on CNI and mission critical systems. So for a bit of context, that's things that help with the safe running of the country. So if you, for example, policing systems and national security systems are typically CNI because if they break, people die, bad people get away, people can't get in and out of the country. It's generally high profile, front page kind of news. So you never want that to happen. I'm quite lucky my projects have never appeared in that category. You also get some interesting kind of requirements that come out of that. So availability is kind of king. You can't have a system that lots of very important people use if it's not available. And also some of the times the data is evidential. So if you're capturing something for a police force, you need to be able to prove the data wasn't tampered with, and you might need to prove that in court. And that might mean, yes, Your Honour, I know exactly what was deployed on that date and time, and it could have been no other way, and it couldn't have been tampered with, which is sometimes something that's a bit off at a tangent to supply chain, but it's a key thing of CNI very often.
Okay, so a few background and context warnings here. So it is a rapidly changing space, so some of you may already be aware of that. Week by week progress is being made by some big players, so Google, Red Hat, Sonatype, etc. There are a lot of COTS products, so commercial off-the-shelf products that are out there, and some open source ones. We'll be focusing mainly on the open source part. There are a lot of aspects to it that are still to be matured, which we'll touch on at the end. It is based on our experience as well, so culture, ways of working, principles that we follow, such as GitOps and things like that. And it is based on containerized apps as well. So if you do sense that there's a lot of Kubernetes jargon, or it's geared around that. So that's just bear that in mind. The talk isn't exhaustive either, so we aren't going to detail every threat out there or every solution out there. We know that GitOps has helped us, but we can't say it's going to solve all your problems. And the last one is hard. It is really hard. Security in software is hard. So we believe investing and shifting left as early as you can actually does help, and you can start benefiting as early as you can from it. And you do want to avoid management coming up to you after watching the Register article saying that there's a new supply chain threat. You do not want that problem, especially if they tell you to start securing your supply chain in 2 weeks of a sprint. So start as early as you can. The motto is don't rush you wouldn't rush the Mona Lisa, so don't rush securing your supply chain. So what is it? What is secure supply chain? So traditionally, a software or supply chain is anything that's needed to deliver your product, as well as the components that go in it. So let's step outside of software for a bit and talk about chocolate. So using a chocolate as an example, the supply chain is pretty much a list of all of the ingredients in it, as well as all the stuff that goes into the packaging and the delivery of it to you. However, it is more than that. It's anything that can affect the production of it as well. So it's a service, the delivery of the chocolate bar. It's also the cocoa bean farmer, the truck that the beans are loaded onto, the factory that processed the beans, everything. However, swapping from chocolate to software, a software supply chain pretty much is the same thing. It's everything and everything that goes into your software. So it can be the code, dependencies and where they came from. It can be additional binaries that you may package as well as part of your software. However, it doesn't stop there. So your software supply chain also includes who wrote it, when it was wrote, who contributed. how often it's been reviewed for security issues, known vulnerabilities, supported versions, license information, etc., etc., etc. And it also includes the stack that it runs on, right? So it's the software that you run as part of your cloud stack that your actual application runs on. So Kubernetes and things like that. It's literally everything that touches it. Now, what is a secure supply chain or software supply chain? I kind of like VMware's take on it, where it's a secure software supply chain is a set of processes used to deliver your software to production, including all of its dependencies, securely, reliably, and consistently with regular updates to source code and defined controls for platform governance. And we'll be talking a little bit more in depth of how you can actually go about doing that. And so, what is, in your opinion, the biggest risk? What do you think it is? Any shout out? What do you think the biggest risk is? Well, in case you didn't guess, it's you, the people. So, new research by Proofpoint in its human factor report, which is an 18-month analysis of data collected across a few global customer bases, revealed that plus 99% of cyber attacks required human interaction to execute, which means you are the last line of defense, essentially. And that's what's called an insider threat. It doesn't have to always be malicious. They can also be negligence and accidental. And that's typically why governments tend to have security vetting, because you might be able to weed out some malicious people based on bad histories, but that still doesn't really protect you from curiosity, laziness, or incompetence. So staying on the topic of risk, they do need to be managed. So here we have a climber. It is an extreme sport, yes, but she still has to perform. So she is mitigating some of those risks. So the obvious one is falling. So she has a harness, she has some rope, and she has some bolted routes which you may be able to see on the wall. But she has chosen to take risks as well. So she isn't wearing a helmet, which suggests that based on her actual expertise, she's made the judgment that the risk of falling debris may be pretty low. So it's bear in mind, please do bear in mind, she isn't reckless. Because if she was, she'd die. She is taking calculated risks based on experience. But she does need to perform still. And secure dev, we believe, is the same. So you still have to perform, you still have to perform to deliver value, but you can't be reckless. So take risks with your eyes open and in a managed way.
Yeah, so we've got kind of a strong opinion on this. So some people would describe security and productivity as kind of on opposite ends of the spectrum. I just don't agree. If you look at the triangle, you've got a bunch of people that are down here. They're very secure, but they're not productive. They might be running on some kind of VMs that are locked down. So the problem you have there is you have latency. You can't get the tools you want. Might be restrictive. There are some amazing tools out there. Things like GitHub workspaces and stuff, code spaces. But unfortunately, in our experience, lots of large, particularly government organisations, find it easier to pay people than buy things. So you haven't got any of that. It's not there. But it's secure. So people kind of have this security kind of comfort blanket. On the other corner is like the Wild West. Everyone's kind of got the Macs. They've got kind of homebrew. They're pulling down bits left, right, and centre. It's super creative. They can do whatever they want, and you have no idea what's going anywhere at all. It's like the Wild West. You kind of want to walk the tightrope in the middle. There is definitely a balance there. You kind of want to be just secure enough without having a problem or a breach, but you kind of want to be productive and not stifle innovation. Kind of leads on to one of the biggest problems, which is culture in our experience. So there's definitely a thing in IT. Developers are particularly guilty of it, of hero culture. For anyone who's read the Phoenix Project, there's this Brent character who's this kind of rock star developer and all the problems go to him, but he's actually a single point of failure and a bottleneck and actually an organisational problem. Very often we see developers kind of getting escalated privileges and holding it like a badge of honour, like, I've got access to production. Like, you just don't want that when it hits the fan. Very often doing the wrong thing is easy and doing the right thing is hard. So when you have things about, no memory sticks, well, they're doing that to move code because you've made moving code so hard. They're going around your security controls. Sadly, very common. No shared responsibility. So lots of projects and teams and organisations talk about doing DevOps, but they don't really. There's an ops team over there and a set of devs over there, and the security guys are probably on another floor. and it's not shared. They're not in it together. It's not a single kind of purpose. Lack of automation. I've kind of lost count of the amount of times I've heard someone say, we'll just do the story and we'll do the automation afterwards. And years ago, that used to be like unit testing. I think we've moved past that. Now it's kind of security and automation. So that's bad as well. And lack of documentation, kind of related to the hero culture. It's all in someone's head. You're always going to the same person all the time. And that around like how you're building your software is a particular issue. So in a bit, we're going to talk about how some of these things are solved. So kind of, I don't know, circa 2010 CI pipeline maybe. You've got a developer, he's using his device, he's writing his code, he's checking it into Git, which is all good. You've got Jenkins doing your builds, so it's not built on someone's machine. Builds an image, in this case containers, pushes it out to package repository, and then pushes it into the dev environments. And it's all right, like it's a build CI system, but there's a load of issues there. And what we're going to do is we'll walk through the issues and iterate on it and then show you where we've kind of got up to.
So Kevin just showed you kind of a standard pipeline that we've seen quite a lot. So what are the threats? So this diagram is created by SALSA, which stands for the supply chain levels for software artifacts, and it details the threats that exist in your software supply chain with a particular interest around the build and packaging areas. Now, SALSA, for those who don't know, is a security framework. So it's a checklist of standards and controls to prevent tampering, improve integrity, and to secure packages and infrastructure in your projects. It's also how to get from safe enough to being as resilient as possible at any link in the chain. So there are 4 levels to it. That each level does provide an increasingly amount of integrity guarantee. And it typically gives confidence that software hasn't been tampered with and actually can be traced back to a source. It's worth bearing in mind the higher up the SALSA, the levels that you go, the more stricter provenance requirements actually get. And in the next couple of slides, we'll actually start to go into a few of these threats in a bit more depth. So, source threat. So, first one is bad code being submitted into the repo. So this is caused by bypass code review, for one. So if someone has access to merge straight to the branch that is the main line, that's one way of introducing bad code, or at least that's a threat, because someone can easily get access to that and submit bad code. And code review that has been had, but it's also missed bad code. So you might actually have a bunch of junior developers on your team, and they start to review their own work, but they don't know the software that well, so they don't know actually what gets introduced is actually bad. And you can actually reduce this risk by, one, having code reviews with at least, you can debate on the minimum of approvers. Some people say 1 and 2, but just have 1 at least. You can, go above if you need to, but just have an actual code review that you do follow. And locking down the main branch as well actually helps, because that then reduces the opportunity that someone can actually just commit bad code to the repo. And another one is stuff like static code analysis. So even if something did get through, before you put it up to a PR, you actually can see that there's security vulnerabilities in your code. So there's OWASP plugins. I know SonarQube does have some really good security scanning tools in their frameworks. Compromised source control. So attackers basically gain access to your source control. Typically tends to be self-hosted. You can reduce this risk, again, protecting it, the obvious one, or better protection. Trying to have commit verification, so make sure you sign your commits as well, so the people who are actually committing, who are actually who they say they are, and try not to self-host unless you absolutely have to. So an example of this actually happening is git.php.net. I know people are thinking, is PHP still a thing? Still a thing. This was the main self-hosted Git repository for the PHP server was compromised by a backdoor that was added by an actor that posed to be one of the official contributors, and they used the official email of one of the contributors. When they realized that, they moved the code from their self-hosted version to GitHub, where they can actually take out that link of being self-hosted. Because GitHub does it, GitLab does it, why not use it? Unless you've got real good reason to self-host, try not to. Build threats. So modify build code. So basically code that's being built that wasn't in source control. You can, again, reduce this risk by providing provenance for the actual sources. So an example of this is webmin. So someone gained access to the build server and modified one of the files to include a vulnerability. The attacker tried to cover their tracks, but ever since, Webmin has actually tried to attempt to prevent similar attacks by actually allowing only checked-in code from GitHub instead of a local file that was being kept in sync, which is what happened in this case. The next one is compromised build platform. So attackers basically gain access to your build server. SolarWinds is the example I think everyone's familiar with at this point. You can reduce this risk again by stronger levels of security around your build platforms. So stuff like scripted builds, so make sure there's no manual steps being done. And this kind of goes hand in hand with the pipeline as code. Text files or build definition files, as they're called, that pretty much contain the definitions and configurations for that build that the build system would then run. So examples would be Jenkins files, drone files, concourse files, build files for GitHub Actions, etc., etc. And they have to be isolated. So build steps, try to run them in an isolated environment, free of influence from other build steps. So, for example, it must not be possible for a build or two builds to interfere with each other when they run at the same time, and it must not be possible for a build to affect the outcome of a previous build or interfere with it, or even the one in the future. So, the reason why we tend to kind of like containerized build systems is because they are quite good at this. So stuff like drone, concourse, Tecton, etc., etc. And bypass CI. So artifacts being uploaded to CI to your image repository or your artifact repository that wasn't built by the CI system. So if someone could just push to it, you kind of want to avoid that. Again, provide provenance for the build artifacts, so exactly what it was built by. And believe it or not, this is actually more common than you think. A common example is actually large multi-supplier frameworks or suppliers want to use one of the in-house util packages, and they deliver it as a binary without even scrutinizing what it is. A compromised package repo for the package and dependency threat. So if you have a package repo that's been compromised, or you're using a bad package or a bad dependency, again, attackers can gain access to package repos by doing this. It can be caused by bad packages or dependencies being pulled due to typo squatting or dependency confusion. And again, reducing this risk by providing the provenance of the actual things being built. So provenance. You're wondering, why is this so common? Again, it kind of comes in hand with Salsa framework. The more you go up, the more it becomes restricted requirement. And provenance is basically the verifiable information about software artifacts describing where, when, and how something was produced. But another one is building your own base images. So try to avoid using the Maven Alpine image that you see on Docker. Try to build your own, because if there's a vulnerability in that base, you then have to wait, or you may have to patch it yourself. It's much easier to build your own base image and patch them, because it is much more a quicker feedback time for that. And hosting your own dependency repository. So making sure that you have trusted sources such as Maven Central, Docker Hub, but making sure that if you do pull from them, you scan the dependencies for CVEs as well. So something like an image repository like Harbor has something like Trivy. Sonatype does this. JFrog, I think, does it with X-Ray, I believe. So making sure you scan them, and then forcing developers to use them. So instead of a developer pulling from Docker Hub, instead set your developers Docker registry to your internal one, and then pull through that. So essentially, nothing gets in unless it's been scanned in the right way, and you're accepting of the risk there. So something that's not covered by Salsa framework, but something that we think is quite important to add, is bad artifacts being deployed in the cluster. So this can be caused by an attacker being able to push a bad image into a cluster that allows for lateral movement or access to anything that you don't want. You can reduce this risk by having policy engines or admission controllers, setting pod security rules that don't allow them to have privilege escalation. It can only run as non-root, etc., etc. And then verifying image signatures and provenance as well. So, for example, a policy engine in your cluster only ever allows pods to be deployed if the image has been signed by the build process. The next one is good artifacts, but with bad dependencies. So standard Java application, Go application, whichever. If you deploy that in your cluster, you're happy with it, it's been signed by your build process, great. However, there's a bad dependency in it that exists, log4j. you can only really reduce that, or one of the ways at least of reducing that risk is by scanning, obviously. Again, policy engine. So even if there's a remote access Trojan in your image, if you have policy engines in place, you can actually set the security rules for your pod, so they're still limited to what they can do.
So where are we up to now? Chris has obviously ran through loads of different fixes, but essentially we now got developers. They're signing their commits, their devices, their dev machines are now pulling from their internal store. We're still pushing into Git, but we've locked down main or kind of master whatever we're using. We've set up a bunch of controls to enforce commits, that kind of thing. We've swapped out Jenkins. We're on a Jenkins bashing kind of thing. Jenkins has got a place, but some of the frameworks, some of the plugins are the Wild West, and personally, we don't trust them for our stuff. Something like Concourse, again, it's got isolation, it's container-based, but there's drone, there's other things. We're pushing into a package repository, but again, that's got scanning. So again, we've had quite a lot of success with Harbour and things like that. And then on the runtime, we've got admission controllers, things like Open Policy Agent, it's quite cool, to enforce things. And something like a service mesh, you could use CNI or Istio to do mutual TLS to kind of stop that horizontal traversal. So if you get things horribly wrong, you've still got like a backstop at the end of it. But yeah, you look at that and you think, okay, that's a lot better. So are we good? Well, not really. You can still do an awful lot better than that. Even now, even without kind of going to the bleeding edge, there's a lot more things you can do. So some improved ways of working, kind of outside of that, is getting your dev teams used to working at least privilege. That's not to say like kind of treat them all like idiots. They all need to be productive, but they need just enough privileges to be able to do their job successfully. And I think to solve that, automation is your friend. Ideally do it at the beginning of the project, so you get return on investment. But if you're going to be releasing frequently and doing builds all the time, which hopefully you all would be, then also it's going to pay back in spades. You need defense against laziness. I would never underestimate the level of incompetence and laziness you can find in a dev team sometimes. All it takes is a public bank holiday and they want to get away on a Friday and it's all a rush. As a bit of an anecdote, I know of a developer he was kind of waiting to get his access to his system, to the client stuff. So he was kind of doing some stuff in his local laptop, a little proof concept with AWS, and it was a Friday, and he just pinged his stuff into GitHub because he wanted to get out the door, but it's a public repo and there's an API key. When he came in on Monday morning, he had a $20,000 bill because someone had picked out his API key and set up a crypto farm in his account over the weekend. So there's a few things there. There's education. He didn't realise what he'd done wrong. He just didn't know. Fortunately for him, our kind of hyperscaler cloud provider kind of reimbursed him, so he wasn't stung, but it scared the life out of him. And you don't want to be that person that accidentally screws something up on a Friday like that. It can happen to anyone. Like if you go and sign up for an AWS free usage tier, it doesn't stop you. It recommends you do 2FA and stuff, but you can do that. So the defense against laziness is some guardrails. Put things like billing alarms on your accounts. Scan your repository for secrets and stuff like that. Have education sessions. Kind of linked to that is kind of making the right thing easy and the wrong thing hard. So going back to the moving code example, if moving code is something where developers are going to go around your security controls and someone's going to get a USB stick out, invest time in automating that to make it easier than actually doing the wrong thing. Optimize for productivity, but in a secure way. So I genuinely believe if you make devs' lives easy as possible, particularly if you're working in a platform engineering team, if your mission is to make them awesome, you'll make life so easy they won't go around your controls very often. Culture of openness. So if someone screws up, put your hand up, learn from it. I've worked with some teams who have some kind of slightly fun things, coffee fines, well done, you made a mistake. You're buying around a coffee and we'll have a chat about it. What tends to compound problems is when people get embarrassed, then they cover up. And it always makes things worse. It always prolongs the issue, makes it a bigger issue. It's more serious. Customers get upset or companies have disciplinary processes. Like, just put your hand up and have a completely open think about it. Make security folks your friends. I think in some organisations they're kind of viewed as like the policemen that are there to kind of stop all these deeply untrustworthy developers from ruining the organisation, but actually the business still wants the stuff that you're writing. They've got a business case where they still want the system. They also struggle with like the ever-moving landscape, just like we do. Like if you look at the cloud-native landscape, there's like thousands of boxes on it. Like how anyone can keep up with that is frankly amazing. They're in the same boat. So make them your friends. Try and find out what they're worried about, what they're trying to mitigate, and then work with them. And 9 times out of 10, you can end up with a bit of a win-win. You won't have some really onerous requirements from them, and you'll do something far more pragmatic. And then lastly, who's your customer? If you're working in a platform team and you're building platforms for your organization, is your customer actually the end business? Maybe, but your immediate customer is probably your development teams. And if your kind of role is to make them really productive so they can build the apps that the business actually care about, then that's a better position to be in. So on the pipeline we had earlier, there was a few things we could do better. And then go back to this point about automation. So I think bots to the rescue. There's a load of things you can deploy a bot and create a bot. And there's those ways to do it. There's kind of HuBot that kind of will talk to kind of Slack and Rocket Chat, which we've used a bit. You can write bots to integrate with Git. So there's those things you can speed up. So a good example is project creation. I'm maybe working in a microservices environment. I want to create a new microservice. So I kind of create a Git repo. Then I have to kind of lock it down and configure it, enforce commits. Then I want my concourse pipeline. That will need a secret. So I go and create that in Vault. Then I probably want to kind of spin the Spring initializer or run some kind of Maven archetype to spit out a skeleton. I've probably got some contract tests. We've got a thing for Pat. When people write these things down, there's loads of instructions. You have to get them all right in the right sequence, otherwise it doesn't work. And it can take people a couple of hours. And if you have a team, maybe not just your own organization, might be subcontractors and the like, people will miss steps and they'll always put their hand up going, oh, this thing doesn't work, it's too complicated. And you can automate all of that. And so we created a bot that did it on a project, but there's things like backstage.io, we can have a recipe, and that will just take that pain away from you. And doing it up front, again, pays back. Factoids is another one. So how many people here have like a little notepad with like useful commands and stuff, so you don't forget them, or it's in your history in your shell? You can stick that in a bot. You just ask it. Everyone's got it then, as well as things like where to go for lunch. Diagnostics and chat ops is another one. So something we've experimented with and it worked quite well was removing all access for developers from our Kubernetes cluster. So if you want to know the status of your pods, you ask a chatbot. The chatbot interrogates the cluster, comes back with the answer, but it also includes the link to Elk Stack. So you've got Kibana, Grafana, Prometheus, and Jaeger links, and you can just click on them. So rather than going into Kibana and then hunting through the logs of the right query, it's at your fingertips. So the thing you've taken away was useful, but the thing you replaced it with is even more useful. And that basically then means there's a whole bunch of accounts you just don't need and don't need to manage. Dependencies is another one. So updating dependencies, there's a new version of a thing, go and test it, see if it works, send a PR. So there's already bots like Dependabot, Renovator. They're really good. Set them up early, again, it'll pay back. Security bots. So there's things like kind of Trivy for containers. I think Snick's got one as well. Looks at your source code. We'll look to see if there's any CVEs in the version you've got. And we'll send you a PR. And also, you can get into a virtuous circle. You can start to add all these things together. So completely by its own accord, you can have PR sent to you because there's a vulnerability discovered last night. There's a new version of a thing tomorrow. And it just keeps updating itself. And the last one is kind of sticking plasters. I think there's a category I'll put that into. So if you're signing your commits and you're using GitLab, it's a bit painful to maintain the chain of all the signatures. So we create a bot to do it because it doesn't get it wrong. So you happy your PR and you tell the Git bot and it just merges it all and your signatures are always perfectly preserved. So if you apply that to the pipeline, you've got quite a lot of different areas. So your developers aren't interacting directly with the cluster. You're doing that through something that's actually nicer. Updating dependencies, in my opinion, isn't even a job for a grad or an intern. It's a script that does it. It's very simple. It's a solved problem.
Okay, so audience question. See how interactive you all are. So how many people in this room are doing what they believe is CI and CD? So just a show of hands. Yeah, show of hands. Yeah, you think am I doing it? Am I not doing it? So those who did kind of put your hand up. Here's a question for you again. If you're deploying, are you deploying things to your cluster from your CI system? or are you provisioning infrastructure from your CI system? So, for example, are you running Kubernetes apply from your CI system? Are you running a Helm deploy, or the version of that, or are you doing a Terraform apply from your CI system? Now, you can think of that in your own mind. Now, I'm going to ask you another question. Imagine you were staying in a hotel where all the rooms on your side of the corridor were connected with a doorway, which some hotels are, believe it or not. They're just hidden. And they're always unlocked. So they're not open, they're just unlocked, okay? Now, imagine if you found out the room that you're staying in is adjacent to a room that a serial killer is staying in the same night as you, okay? So you're sleeping in a room next to, your room is next to another room which has a serial killer in over that night. Question for you, another one, is would you trust that he isn't going to come through that doorway in the middle of the night and kill you? Probably wouldn't. This is kind of like the situation when you give your CI system access to your deployment infrastructure. So you saw the diagram change slightly when Kevin changed the slide. The only thing that has changed has been the lines that's gone from the CI tool to the environments. That line's now going from source code, right? Now, the typical pattern that we try to at least go with is separating that out, because otherwise your CI tool has write access to your code, write access to your image repo, write access to your Kubernetes cluster, and it has write access to your account that everything lives in, right? What if it was compromised? It's got the keys to the kingdom in a lot of cases. Enter GitOps, we believe. So using GitOps, it allows us to separate out that CI and CD parts, right? So again, red lines. All infrastructure and app config is actually now in Git, and you have Git operators that exist in your cluster or your environment that applies that state, right? So the access model is different. So the push model of CI tool to the environment is now on a pull model basis, okay? The good thing about this is it's easily updatable. It's easy to roll back. It's easy to rebuild environments, because if your cluster goes down, it's fine. Provision a cluster again, just point it to a Git repo. It just provisions everything to the way it was before. Now, tools that we've used in the past, open source tools, things like Atlantis work quite well with infrastructure. So it's like a wrapper around, well, not a wrapper, but it kind of runs Terraform for you, and it's like a pull request based workflow. It's really, really good. And if you're using Kubernetes, things like Flux are really good tools for this as well. You just install them in your cluster, point it to a Git repo, and say, whatever's in there, apply. And it just does that. It also works with Helm pretty well as well. Now, the good thing about this is the access credentials for each part is now separated. So they're now not all in the CI tool. You have Atlantis, which has its own thing. So if you really want to gain access to the infrastructure, instead of compromising the CI tool, you're going to have to know where it is now. And accessing Atlantis is a lot harder than just having access to a CI tool if you compromise it. So this is actually one way of avoiding hacker kiddies, maxing out your AWS account, because the chances are they don't know where the creds are, and you put them in certain places where they can't access. Another case that we've seen is CI access to databases. So how many people use their CI system to run database scripts? Some use the CI system to do that. Try to aim to lock off that connection, but make sure you put measures in place to allow devs to still provision database schemas. Things like Liquid-based Flyway are actually pretty good for this. So your application starts, it automatically provisions it sets up the schema for your databases at runtime. So you don't have to worry about running ad hoc scripts anymore via a CI job. But again, it's important. Do not lock off your database access to your CI environment. Sorry, database access from your CI tool, unless you've got a measure in place, because otherwise developers are going to come to you and say, I have this to do, how do I do it? And then what you end up with is really bad things. So something I'm familiar of, which happened, or I heard, that happened. The CI tool had no access to the databases. The devs were like, well, how do we provision stuff? So what they did, they found out that the applications themselves have access to the database. Okay, where do we go with that? How about we install a PSQL client, Postgres command line client, in the Java application? and then access the database that way. And that's what they did. So they essentially went into the pod, they installed the pSQL client in the pod, they then run a bunch of queries against the database to provision the database schemas, and then obviously didn't remove the pSQL client afterwards. So if a hacker got hold of that, he goes, oh, I've got a pSQL client, oh nice, I've got access to the database, I've got everything. Try not to do that. And the reason why that was possible is because the right thing was hard and the wrong thing was easy. So if you try to aim for the wrong thing, the right thing's easy and the wrong thing hard, you actually end up with a pretty decent solution in the end. And by the way, there are ways of limiting CI privileges, sure, but this would then mean that you have to then go in and exactly allow or disallow what a CI tool can or can't do. It's much better to just separate them out completely. A CI tool is good for CI. Use CD tools for CD things. Don't use a CI to do everything. As an industry, we love just going full hog on one thing. And again, we prefer GitOps as well in combination with separating these out, because not only do you get the benefits of GitOps, but you also get that clear enabling separation. So
that obviously from the first pipeline we showed, it's changed quite a bit, and things have moved on. And it's a lot better. And if you were there, is it working? Yeah, if you're there now, it's still good, but there's a lot further to go. So, for example, what it doesn't address is if Chris made a change, how do I prove Chris's change is actually in production and no one else's? How do I know when my pipeline ran that someone didn't go in and just disable the unit tests because they couldn't be bothered because they're too slow? Right, I've seen that happen. How do I know the actual right steps in the pipeline happened? How do I know that someone didn't go in and disable my static analysis on my code pipeline because maybe the code wasn't good enough? Again, seen that happen. So even though you can have lots of controls on the previous slide, it doesn't categorically stop that. You can't prove it actually happened. And I think that's where secure software supply chain is going. Sadly, it does mean quite a lot of the boxes changed, quite a lot of the tools changed, but that's kind of what we're looking at now, and our internal stuff. That's what we're using now. So we'll start to talk through that and where some of the gaps are and where some of the things aren't mature. Kind of watch out, but it's an ever-evolving space. So start off with the basics. So code. This is something you can control. So we talked about signing commits. Typically GPG keys for us, some of our stuff. SSH, but you could use cosign. You can use lots of kind of certificate-based things. So you sign your code, you put it into Git, and that's fine. Where it starts to get a little bit more complicated is it's the other stuff you're pulling from somewhere else, the stuff you don't really control as much. So if you're building containers and you're building, say, Java stuff, you're going to be pulling some language kind of features. You're going to be pulling some operating system kind of packages to stick in your container. And some external dependencies as well, Spring or bits of Quarkus, whatever. If you're pulling in external packages, and they've got signatures, make sure you verify them. It's quite common for people to be pulling from Maven Central, and they do nothing with the checksums. They don't even check to see if it is the thing it purports to be. If you're using NPM, good luck, because it hasn't got any of that. Lots of people now are starting to create SBOMs, so software bill of materials, and they're quite nice. So if you're pulling, say, a large framework and it's got an SBOM, that's basically saying what's inside it. It's a really easy way to then keep continuing scanning it and say, well, is there a CV and is there a vulnerability in it? And just because there isn't today doesn't mean there won't be tomorrow or next week or next month. So yeah, if you consume SBOMs, it's good. And also in the CI pipeline, you've got a number of different tasks. And then what Chris is going to get onto is how do you prove those things actually happened? And how do you get your cluster to prove that actually happened?
So next step. So containerized apps, again, helpful warning at the start. We've done a lot of stuff with containerized apps. So for a container, you have images. Obviously, the image is now in a repository somewhere. So some people use ECR. Docker Hub, there's many different types, Harbor, Key, etc. And then on the other side, then you have image signing, right? So there's kind of two main areas, at least we see. Notary, which is backed by the update framework, or TUF, and you have a DB as well. Whereas cosign is kind of somewhat a collection of tools being used by the Sigstore guys. Really, really good stuff over there. And again, it's a way of signing your images, right? So if you have a CI system that builds your Java application, Go image, Perl if you're still using Perl. You build the image, you sign it, you push it. And funny enough, Harbor actually just recently put a new version out that allowed you to actually push signed images from cosign as well, which is nice. But yeah, as you see, there's a few tools related to the cosign area. Not going to go in detail of all those. They are quite literally a talk in themselves because, as I said, it's a lot of stuff with security, especially when you involve PKI in it. But there's a lot of good work being done by the guys at Sigstore in that area. So really, really put that on your read list. And the next step then is CI system. You've got your container, you built it, but then what happens then? You kind of want to secure your build. So currently, Tecton and Tecton chains is kind of the places, or at least the thing that we see at the minute that does this natively. And it basically allows you to build images and sign them. Great. But it does a few other bits and pieces, right? So with tools from the Sigstore project, like cosign, for example, you are able to sign the images. Great. But then Tecton chains, when the task is finished, really cool. In its default mode of operation, it works by observing all the task runs, executions in your cluster. And a task run is, something like a concourse task or drone task, whatever. And it observes them. And then when it completes, Chains takes a snapshot of them and then converts that snapshot to one or more standard payloads and signs them, stores them somewhere, Harbor, for example. So not only do you have an image that is signed by the build, but you also have provenance, which in and of itself is the attestation that says Tecton produced the image under the conditions that it was built by. So you can then take these attestations and verify them later on when it comes to policy engines in your cluster. So stuff like Kyverno allows you to say, this image, who was it built by? Not Tecton? Nah, I'm not liking that. Is it verified? Is there an image signature? Is there one? Nope, not accepting that. Only accepts the images that you expect by the signature. It only accepts the images that are signed, and the images that are signed by the place that you expect it to be signed by. So again, extra levels of security. And again, this also determines whether, if an image has been built, you can see the pipeline tasks that would run in order to build that image. So you can easily see if someone pushed something to the cluster on a Friday and said, and they just disabled the unit test. Like, you could just see that they've done that because it's in the file, it's in the attestation. Now, further work is being done to tie Tecton to Spiffy and Spire. Again, like we said at the start, this is kind of the frontier of security in software at the minute. So there's a lot of big players contributing to this space. And then you've got the last bit then, which is the runtime aspects. So this is where having things like admission controllers and policy engines, such as Open Policy Agent or Kyverno, is kind of the Coke and Pepsi at the minute, I can see, to verify that the images that you do deploy, as I've said earlier on, they actually are signed and meet the security requirements that you've set. You also have additional features such as setting policies with pods. So as I mentioned earlier on, not allowing privilege escalation, not allowing non-root containers. So even if someone does get in, they can't do much. So stuff like CNI, things like Calico, again, extra levels of security on the network front. So you can set network policies to enforce rules whether traffic is allowed or disallowed. Again, extra level of security. Something that's not on there but is worth mentioning is service meshes is an obvious one. Mutual TLS between pods is another thing to have, and also Spire as well. So which basically allows the workload or node attestation by allowing trust between services. So Spiffy is something that's also used by Istio to help with Istio and Envoy to help with MTLS between pods. And then Flux as well, which I've mentioned before, which basically is a GitOps operator that we spoke about that reconciles your state of your cluster with what's in Git. So I've kind of whizzed through them. Honestly, each one of them are topics in themselves, if I'm honest. They are really, there's quite a lot of detail there. But I just kind of want to explain to you where things are going, or where you can, and if you don't have all of it, it's fine. But as Kevin will talk about in a second, you can start somewhere.
Cool. So yeah, Chris said it's still a work in progress. There's loads here. I'm sure if you go and chat to some of the vendors outside, they'll have products that have bits of it. Our experience is organisations that find it easier to pay people than buy things. So very often we end up with a DIY approach on some of this stuff. It is hard. I think one of the biggest things was the original kind of Jenkins pipeline we showed. That's something a Java dev could do. You can hold it all in your head. Okay, I pull from Git, I build the thing, I run a Maven build, and off I go. The last slide is just immense. It's just so complicated. It's a whole specialism in its own right. It's not something you're just going to give to a Java dev on your team. Just set me up a build server, off you go. It's a proper engineering task, and it's maturing. Like S-bombs, there's 2 standards for it. You probably have to support both of them because you're not going to get to pick and choose. So yeah, it's work in progress. Tooling needs to get better. Text on chains, we think it's quite cool. Like, it seems to be the only thing we can see that does all the things we want it to do. Not just from a security perspective, but from a quality one as well. Did you actually run on your test? Did you run on your static analysis? If someone disabled it, I want to know. S-bombs, there's a bit of immaturity. The tools are coming all the time, but they're good things. It's kind of the future. Emission controllers can help enforce a lot of that policy on your runtime, on your Kubernetes cluster, and can also help enforce kind of security best practice, like pod security standards. So if it does all go wrong, you're still going to be in a better place. And attestations is kind of a really important thing, not just for security, but if you have a particularly picky test manager, for example, saying, yes, I definitely ran my unit tests and my integration tests, they definitely happened. And you can see they did because they're in a public attestation log. It's quite cool. So, kind of a few takeaways, some things to think about. You can't really have like proper zero trust and all this stuff yet. There's still a bit of a who's watching the watchers kind of problem. So you're putting these things in that are going to prove your pipeline actually did the things you said it was, but how can you actually trust that thing in the first place? There are some ways of kind of bootstrapping some of this stuff, so it kind of builds up its own kind of trust from nowhere. But it's hard. It's not a trivial thing. I think if you, my definition by the way for hard would be, can you just give it to your kind of average platform engineer or your average dev? And the answer to some of this stuff is no. You're going to be pulling out the best platform engineers you've got for some of this stuff because it's tricky. But you can have something now. Definitely do that. Like if you're on the first Jenkins build pipeline model, I definitely recommend looking at some of the other controls because you can make a massive difference really quite easily. Produce S-bombs for your stuff. Even though they're not massively useful in all cases right now, they will become more useful and things are going to standardize around it. Use Salsa, even internally, just so you can kind of plot out where the gaps are. And it's fine to take some risks. It's fine to go, I haven't mitigated that risk, but you're doing it with your eyes open. And use bots. Updating dependencies is not a job even for an intern or a non-developer type person. And where you do find those gaps, you can kind of sticky plaster some of them. If you apply the same kind of mindset that like some DevOps teams have about automation and infrastructure as code, I think people miss the dev part of DevOps very often. Like apply that same mentality to the dev bit, you can go a lot faster. And you can spend all your time concentrating on proper things like delivering apps to businesses, not running around copying and pasting commands. So that's us. So if you've got any questions, I think you've got 3 minutes left, or you can come and find us on the stand. Thank you. Question over there.
I noticed that you didn't mention GitHub Actions at all in any of those technologies. I wonder if you have any views on it.
Yeah, so we've played around with GitLab CI and a little bit of GitHub Actions, and the main reason is it's our experience. So GitHub's great, I really like it. Do all our big customers use it? No, like it's expensive. But there's some really cool stuff. So like the productivity kind of triangle stuff, like the code spaces stuff looks really cool. That would actually solve a lot of problems in that space, and GitHub Actions would. Some of the kind of like the security, I think the SNCC security bot plugs into that. Internally, we've got like an engineering blog, and we use some GitHub Actions. So we use that stuff for our own kind of public-facing blog and stuff we play around with, and it's brilliant. It just doesn't seem to have made traction into that the kind of domain we spend a lot of time working in. Sadly.
Yeah, there's if I was to, if I was to like rank tools that you could probably use for some of this stuff, GitHub Actions definitely not last. I've not got expertise in it, but when I was doing some of the work for Tecton, I realized that there were quite a few articles that actually did use GitHub Actions in some of them. So I believe there are quite a few things you can do in it. I think the reason why Tecton Change kind of stands out for me, at least, is because it seems to be the only tool that natively does what it does. Sure, you can probably get image signing in Concourse. I mean, you can, obviously, yeah, you can. Drone, sure, but then it's the secure build part, which is how do you verify the step that was made? How do you put all that into an attestation? Tecton Change kind of does that, and that's the extension for it. And as far as I'm aware, that's the only thing natively that does it, without you having to kind of go to the nth degree to put that in. But yeah, GitHub Actions, I think, is it judging based on some articles, it looks like that's actually something that people are doing quite some good stuff with. But again, I don't know the actual length of where that stops. I don't know if it's as good as Tecton Change at this point.
Cool, thank you. And time's up. But if you've got any more questions, come and find us. We'll be on the Capture My Stand. Cheers. Thanks.